This video is a follow-up to the previous video where I ported the System Workbench demo project to CMake. The porting was successful, but the resulting project was unusable because the resulting project contained many absolute paths to the Cube F7 firmware. For example, the header files and static libraries were specified using absolute paths. Also, the GCC Toolchain, OpenOCD binary, and OpenOCD config files that were used came from the System Workbench installation. In this video, I will remove all of those references so that the CMake project is completely standalone and not dependent on the Cube F7 firmware. Also, I will install the GCC Toolchain in the container and install OpenOCD on the host, so we no longer need the System Workbench installation. So, why do you want a standalone project? Well, you don't want your project to live inside the vendor. The vendor should live inside your project, or be neighbors with your project, if you will. It's all too tempting to start with what the vendor gives you and say, oh, I can do hello world. Let's just go straight ahead to developing features and I can impress my boss with a demo so fast. Well, that will bite you later. Remember that the vendor organizes the code that you're given for the vendor's purposes, not your purposes. Remember that the vendor has to support tons of different targets and platforms with a single code base, and the vendor has many engineers working on this gigantic piece of work. The result of this is a giant pile of spaghetti that you should diligently isolate and protect yourself from. If you let all the extra vendor stuff stay in your project, you will find that your project has dependencies that aren't necessary, and your builds will break for reasons that have nothing to do with your actual project. Another reason you want to keep your codebase clean is so that when you use C tags or C scope or whatever, you don't want ambiguities. If you want to look at a particular symbol, C scope should know exactly what symbol you're talking about. If you want to look at a header file, there should only be one header file to go to. And as I pointed out in the last video, the Cube F7 codebase has ambiguous files which only serve to confuse you and slow you down. Every vendor has bad things in different ways. Don't rely on vendor packaged tools, in other words the toolchain. You should be fully in control of your toolchain. If you get too far in your project under the convenience of what the vendor gave you initially, it will bite you later when you realize you don't know what version of the compiler you're using, you don't know why the size of your binary isn't as expected. You spend a whole day realizing the linking step had a dependency on the order of which the libraries and object files were listed, etc. Anyone that does web software or non-embedded software will tell you that you need to have a complete end-to-end pipeline before you even start your first feature. When I did that type of work, we had Jenkins already set up to build our project, and our platform as a service already set up to host our binaries in a production or test environment. And this was all automatically set up to happen after a git push. In other words, we were set up to launch the product as soon as the code was developed. In the embedded context, there aren't as many tools, and the tools aren't as complicated, so you should be able to demonstrate all of their uses before you start working. If you don't, and just use what the vendor gave you, there will be a time when you stop using what the vendor gave you. So you need to shake out these problems as early as possible because later this type of stuff is extremely time sensitive and mistakes are more expensive. This means stuff like, are you shipping ELFs or hexes? How are they labeled, versioned, and packaged? Why is it that your coworker can't build the code but you can? Why is it that the contract manufacturer can't flash your code but you can? Contract manufacturer says your hardware is damaged but you think they have the wrong firmware. How do you resolve? All of these issues are much easier to resolve if you focus on end-to-end ASAP. Bit of a recap here. You should be in control of how clean and awesome your codebase is. If you are stuck in a messy, tangled up environment that you took from your vendor, you aren't going to want to do nice, clean things because it's too risky. You've gone too far and you don't want to break anything. Just a silly example here. I've had experiences where I wanted to reorganize my include directories, moving stuff around, and then wanted to add 10 or 20 include directories to the project. But I wasn't able to add them all at the same time. The IDE forced me to use their GUI to add them all one at a time, and this discouraged me from doing it. I asked myself, am I not supposed to do that? So again, don't let the IDE or the vendor determine how clean and awesome your code base is. Okay, enough of that, let's get started. So the container I'm using for this video is based on the image from the last video where the port to CMake is complete. This container has access to the downloads directory where the Cube F7 firmware package is, and this standalone CMake project is simply a copy of the last project, the port to CMake project. Basically just renamed it. Note this container does not have access to the system workbench installation, meaning it does not have the GCC Toolchain. So the first thing I will do is install GCC. Alright, let's start it up and shell into it. So notice the standalone CMake project is there. The other directories from the last container are still there. Nothing's inside of them, but I can't remove them. Not sure why. If anybody can answer that, that'd be great. Alright, I'm here in the project directory. Gonna switch user here. And I've deleted the build directory, so I'll make a new one. Go into it, run CMake. And as expected, CMake cannot find the toolchain at this path because obviously it's not there. So now I'm going to install the GCC toolchain. Now you can get it with apt-get. The version will be out of date, so definitely go ahead and get the toolchain directly here. It's super easy to get it. Now, Firefox is not running in the container, so I'll copy the link and let's give Docker user access to the opt directory. Docker user opt. Oops. Okay. Switch back. Okay, and now wget. Oh, I don't have wget. Okay, back to root. Wget. Install that. Okay, back to Docker user. Back to opt. Now let's download that link. It's a pretty large file. Alright, got it. Now, oh, it didn't give me a nice name, but this is a tar.bz file, so xvf, and it's extracting lots of files. It's just cluttering up there. So what did we get? We got in the bin directory here we have the toolchain. So if I run GCC version, we get GCC 8. And note again, if you just do a regular apt-get install of the ARM toolchain, you'll get something like version 4, and that will work for some processors, but not the STM32F7. So definitely make sure you get a recent version. Okay, now I can go ahead and update the path to this toolchain in the CMake lists. This is all left over from the previous video when the porting was done. So here's the toolchain path, and we're simply going to replace that here. And let's see if that worked. So if we go back into the build directory, my mistake, gotta put the /bin after it. Okay, and it built. Okay, now I can remove the STM cube firmware references. So these are the include directories here and the static libraries here. So let's get rid of these header file dependency paths. So I'm going to copy these, and I'm making a script to do this copying. Now let's open that. Okay, copy those in there. Now I want to just extract the paths here. So let's get rid of white space and the closing parens and the quote. Okay, now for each one of these directories I want to take all the header files in that directory and copy them to another directory which has a different prefix here and the same suffix. So I will define a macro, take a line, move it to the bottom, copy it twice, make dir -p, remove the prefix, temp/headers, copy all of the header files into this directory. Test it out. Then I can say get a region and apply macro to region lines. Okay. I don't know why I got a bit screwed up here. Comment that out. Now let's try to run it. Okay. So it didn't exactly work, but it mostly worked. Now the reason nothing showed up here is because there aren't actually any header files at those paths. It means that the compiler invocation specifies include directories, but the source is looking at header files at a relative path to that include directory. We'll just fix that manually when the time comes. So I can move the headers into the project. So I have the headers here. Now in the CMake lists, I can change the prefix here. What do I want it to be? Source root dir / headers. Let's give that a try. Make. Can't find it. Let's see what happened there. Huh. Okay, this is not right. We'll just change that to not go up a directory. Yeah, source root dir is just the dot there. Yeah, I guess this list, when this is being created, is different from when include directories is being called. So let's try again. Huh. Right, so here's this relative path. So the source file is looking for the header at a relative path, and the step that I just did is only copying headers that are inside of these include directories. I wanted to do a recursive copy of the header files, but couldn't figure that out quickly enough. So anyway, I'm just going to copy that legacy directory over. So first let's create it. Headers, drivers, PAL driver, inc, legacy. Yeah. And copy from the STM cube, PAL driver, include legacy, copy both of those to headers, drivers, PAL driver, inc, legacy. Okay. Okay, same thing here. It's a relative path here. Right, so this is where that header file is. So it wants to go up to BSP and then into components. But nothing is there. I'm just going to copy that entire components directory. So what's there now? Drivers, BSP, component. Oh, sorry. Headers, drivers, BSP, components. Spelling error. Yeah, those were there because I copied them over in the previous video, but now we need some of the other ones. So let's go ahead and copy them. I'm just going to recursive copy everything. Downloads, cube, drivers, BSP, components. Copy those over. Tree, headers, drivers, BSP, components. Okay, looks like I got them. Let's try this now. Ugly. Yeah, so don't have that. Fonts, let's just copy it over. Fonts. So downloads, cube, utilities, fonts. Recursive into headers, utilities. Okay. Make f.c. It includes a C file here. Where is it? Add-ons. Oh, right, that it wasn't exported. Dang, this is ugly. What's in there? Oh, we have headers. Well, just do this super manually. Okay, I'm putting it in headers even though it's a C file. Cancel. OK, cancel, and up. Okay, cancel and OK. You're going to get copied into here. in the build directory. So go up one. Okay. And it continues on. Now expecting to see missing headers in the lightweight IP section. Alright, get that lightweight IP missing header. So let's do the same thing. Let's see, where is lightweight IP? Okay, copy, downloads, cube, middlewares, third party, source. This wanted net if WIP lowercase. Ugh, terrible. Net if. What do we have already? Middleware's third party. Oh, I see. We have this directory, but nothing's in it. So let's copy. Is there anything else in here? Yeah, lots of stuff. Let's copy all of it. Oh, some of these are directories. Alright, let's see what are. Huh. Does that work anyway? Net if. That's the same thing. Where's third party? Oh, it's right there. LWIP. Oh, I put them in the wrong place. Oh, why did I put the star at the end? Okay, just take out the star. Headers, middlewares, third party. Alright. Arch CC. Where's that? System. Yeah, I don't really care about lightweight IP. It's gonna get removed anyway. I just want to make this work for now. You know what? Let's just copy the whole thing. I don't care. Go, go. Don't stop. Yay! God, that's ugly. Well, that was awful, but almost done, and this should be easy. So the static libraries here need to be copied over. So let's find them. STM-win add-ons. Let's see, I'll make a directory called static libs. Find. We're going to take the 769, copy it into and OT. Okay, copy that. And BDM filter. Okay, and can take out the prefixes of the paths. Okay, I just learned something here. So you can put in flags here in target link libraries. And I put in this -L because of the naming convention here. Doesn't have the lib prefix for these libraries, so the colon will search for this file name literally. And now it works. Great. Now, just as a sanity check, I want to move everything out of downloads and run the build again just to make sure that I didn't miss any hidden reference to inside of the downloads directory. I actually decided to do it from the host. So anyway, this volume mounted downloads directory is now empty. So if I go back into the container, there's nothing in downloads. So I can run a clean build now. Do make clean, make. Well, it builds, but oh no, I'm getting a warning about packed attribute ignored. That doesn't sound good. Can't remember when this came up, but it definitely came up at some point. Not good. Okay, I'm suspecting the compiler warning has something to do with the toolchain that I downloaded. I downloaded the latest one, but the System Workbench toolchain is from 2018, last year, so I'm gonna download that same one and see if the warning goes away. Okay, I downloaded and unzipped the GCC 7 from 2018. I'm gonna copy that. Now go into the CMake lists and change this here do a brand new build here. Build again. Yeah, very, very odd. The compiler runs much faster simply by using the older version. Indeed, the compiler warning is not there. Very odd. Looking at the latest, or the changelog, not really sure what to make of it. Yeah, I don't know. So I'm not going to look further into this. What I'm going to do is I'll use the GCC 7 from 2018 just because it's faster, and that's the one that System Workbench supplied. So even though I'm not going to get to the bottom of the issue, at least I feel that I'm in control because I am explicitly choosing to use GCC version 7 as opposed to just blindly using what I'm given.